Hi students, welcome to my class. In this video, we are going to learn about force and pressure, 11th chapter of science. So, let us move on. Main contents of this chapter are: force, a push or a pull. Forces are due to interaction. Exploring forces. A force can change the state of motion. A force can change the shape of an object. Contact forces. Non-contact forces. Pressure. Pressure exerted by liquids and gases. Atmospheric pressure. How will you move a ball which is at rest? Yes. You can kick the ball with your leg. You can push the ball with your hand. You can throw the ball with your hand. You can also hit the ball with a bat to move the ball which is at rest. Consider a ball which is moving in the ground, and you want to make that ball move faster. What will you do to make that ball move faster? Yes, you will hit or strike the ball strongly with a bat. Or, you can also give a strong kick or push. By this way, you can increase the speed of a moving ball. Let us take another case. Imagine, a ball is moving towards you in a great speed. What would you do to stop that speeding ball? Yes, you would certainly catch it, isn't it? So, you will definitely catch the speeding ball, which is coming towards you. Let us take another case. What will you do to change the direction of a moving ball? Yes, either you can place a barrier in the path of the ball, or flick the ball with a stick, bat, hand, or your leg. Thus, we can conclude that a force must be applied to move a thing at rest, to make it move faster, to slow it down, and to change the direction of a moving body. Some examples are: the man is lifting his books. He is picking fruits from a tree. He is opening and shutting the door. He is pushing the shopping cart. If we analyze the previous examples, we can see that almost all our daily activities can be grouped under two categories: push and pull. The actions, shutting, hitting, kicking, poking, pressing, squeezing, stepping, ringing, and drilling comes under the category push, because in all these actions, one object is being pushed by the other. The actions, lifting, dragging, opening, stretching and tugging comes under the category pull, because one object is being pulled by the other. So, we can conclude that a push or pull is necessary to move an object. A force may be defined as a push or pull on an object. Now, let us try to know what happens when a force is applied to a body. When a force is applied to a body, a stationary object moves, a moving object moves faster, a moving object changes its direction, a moving object stops, and the shape of the object changes. All of you are familiar with the game tug of war. Each team is pulling the rope from the two sides with their whole strength. Here the force is applied on the rope by the two teams. In the second figure, you can see the arm wrestling competition. In this case, we can see that the two persons are pushing each other's arms. From these examples, it is obvious that two objects need to interact with each other for a force to come into play. An interaction of one object with another object results in a force between the two objects. Look at the man. He's trying to move a heavy box, but he can't move it. Why does this happen? Because the force applied by him on the box is not sufficient to move it. Here, two men are pushing the box towards the same direction. Now they can easily move it. Do you know why? Yes, this happens because forces applied in the same direction gets added up, and this made possible for two men to move the heavy box. Look at this scenario. Two guys are trying to push the refrigerator from opposite directions, but they can't move it. Why does this happen? They are exerting equal forces from opposite directions, so the force gets cancelled. Two equal but opposite forces acting on an object makes the object immovable. Look at this. Here two guys are pushing the refrigerator with their maximum force. The third guy pushes it from the opposite direction. Did you just see what happened? The refrigerator was pushed towards the guy who was pushing it with less force. If two unequal forces act in the opposite direction, the resultant force acting on the object is the difference between the two forces. In the case of equal forces, net force on object is zero, so it will not move. In the case of unequal forces, net force is the difference between forces and the object moves towards the force with less magnitude. From all that we have discussed so far, we can infer that a force could be smaller or larger. The strength of a force is usually expressed in magnitude. It also has direction. If more than two forces acts in an object, the effect on the object is due to the net force acting on it. A force can change the state of motion. How? If we apply force to a moving object in its direction of motion, the force will get added to the actual speed of it and it moves with greater speed. If we apply force to a moving object in the opposite direction of motion, it opposes the moving object and as a result, the speed decreases. So we can say that if we apply force, a change in speed or direction occurs. This change in speed or direction of motion or both are described as a change in its state of motion. Force results in change in the state of motion of an object. The state of motion of an object is described by its speed and the direction of motion. The state of rest is considered to be the state of zero speed. An object may be at rest or in motion, both are its states of motion. All of you must have know how to knead flour to make dough. You will press it, punch it, roll it, right? What do you notice there? We can knead it into a sphere, a sheet or whatever shape by just applying force on it. Look at the first picture of a car crash. The car with the maximum speed has collided with the maximum force on the other car. The shape of the two cars at the point of contact has changed due to the force of the car. In the second picture, a metal rod is being heated to maximum and bent by hitting it with hammer. Here the shape of the rod has changed due to the application of force by the hammer. Forces are of two types: contact forces and non-contact forces. Try to move a ball without touching it by any means. Is this possible? No, isn't it? Try to pick a pen or a pencil or box without touching it with your hand. Do you succeed? No, right? That is, to move, lift or pick anything, two objects must come into contact with each other. Forces that come into action when two objects are in contact with each other is known as contact forces. Look at these two pictures. A man is stretching a band with his legs. In the second case, it is a bullock cart. Two bulls are pulling the cart. In these two cases, force is caused by the action of muscles in the body. Look, here one person is squeezing a lemon. He is also exerting force by the action of muscles. Similarly, the other figure shows a man lifting a heavy rock. He is also applying force by the action of his muscles. Since muscular force can be applied only when it is in contact with an object, it is also called a contact force. Let us look into some other examples. How do you light a matchstick? You would rub the matchstick against the side of the matchbox. Here the two objects come into contact by rubbing. A force comes into play, which is the force of friction. When we walk, actually friction holds our toe to the ground. Without friction, we can't walk. We can't hold any object in our hand if there is no friction between our hands and object. The force of friction always acts on all the moving objects and its direction is always opposite to the direction of motion. Since the force of friction arises due to contact between surfaces, it is also an example of a contact force. What is frictional force? The object exerts a force on the surface and the surface in return exerts force opposite to the direction of motion of the object. This force is called frictional force. Forces that come into action, even when the objects are not in direct contact with each other, are called non-contact forces. When we rub a balloon on our head, opposite charges build up on our hair and balloon. When we pull the balloon away from our head, the two opposite charges attract each other and thus our hair sticks to the balloon. If we comb dry hair using a plastic comb, the comb gains electric charge and the hair is left with positive charge. When the comb is moved over a bit of paper pieces, the charged comb induces a dipole in the bits of paper and the paper pieces gets attracted towards the comb. In these two cases, forces are exerted by a charged body on another charged body. This is called electrostatic force. This force comes into play even when the bodies are not in contact. So, this is a non-contact force. A ball falls back to the ground when it is thrown up. Ripe fruits fall to the ground. We all know that it is due to the force of gravitation by the earth. This is an attractive force. Every object in the universe, whether small or large, exerts a force on every other object. This force is known as the gravitational force. The force of gravity acts on all objects. The force of gravity acts on all of us all the time without us being aware of it. The gravitational force comes into play even when the two bodies are not in contact with each other. So, this is also a non-contact force. Like poles of two magnets repel each other when we try to bring them closer. But when we try to bring the two unlike poles close to each other, it will jump and stick together. That is, unlike poles of two magnets attract each other. A magnet can exert a force on another magnet without being in contact with it. The force exerted by a magnet is an example of a non-contact force. Try to hit the nail to the wall by its pointed end. It's quite easy to pierce the pointed end into the wall, isn't it? Why is it so? Try to push a nail into a wooden plank by its head. What did you notice? It's difficult to pierce it into the wall. This is because, in the first case, the area in which the force acts is small, and in this case the area in which force acts is large. As the area increases, the force that we apply is divided onto the whole area. Thus pressure applied decreases. The force acting on unit area of a surface is called pressure. Pressure is equal to force divided by area. The smaller the area, the larger the pressure on a surface for the same force. Shoulder bags are provided with broad straps, not thin strap. Because if broad straps are used, weight of the bag is distributed to a large area than thin straps. So it will not cause pain to the shoulder. Also, the tools meant for cutting and piercing always have sharp edges. This is because to cut anything, large pressure is needed. For that area should be smaller. Sharp edges have very small area. Pressure exerted by liquids and gases. Look at the picture. Water from the upper hole flows out with little pressure, but water from the lower hole has maximum pressure. The pressure exerted by a liquid is small, just under the surface of the liquid. But as we go deeper in a liquid, the pressure of liquid increases. Take a used plastic bottle. Drill 4 holes all around near the bottom of the bottle. Make sure that the holes are at the same height from the bottom. Now fill the bottle with water. Note the distance from the bottom of the bottle to the points where the water falls on ground. The different streams of water coming out of the holes fall at the same distance from the bottle. Liquids exert equal pressure at same depth on the walls of the container. Take 2 tubes. Stretch a rubber sheet or balloon at the bottom end of the tubes. Pour water to the 2 tubes. You can see the rubber sheet bulges out. The amount of bulge is higher in tube with maximum height of water column. That means pressure exerted by water at the bottom of the container depends on the height of its column. The rubber sheet has been fixed on the side of the container and not at the bottom. As the amount of water in bottle increases, the bulge increases. This shows water exerts pressure on the walls of the container. Similarly, gases also exert pressure on the walls of the container. The pressure exerted by the air is known as atmospheric pressure. If we imagine a unit area and a very long cylinder standing on it, filled with air, then the force of gravity on the air in this cylinder is the atmospheric pressure. When you press the sucker, most of the air between its cup and the surface escapes out. The sucker sticks to the surface because the pressure of atmosphere acts on it. To pull the sucker off the surface, the applied force should be large enough to overcome the atmospheric pressure. If the area of my head were 15 centimeters multiplied by 15 centimeters, how much force air will exert on my head? Area equals 15 centimeters times 15 centimeters equals 225 times 10 to the power minus 4 meters squared. 1 atmospheric pressure equals 10 to the power 5 Pascal. Pressure equals force divided by area. So force equals pressure times area, which is equal to 2250 Newton. The force due to air in a column of the height of the atmosphere and area 15 centimeters times 15 centimeters is nearly equal to the force of gravity on an object of mass 225 kilograms. The reason we are not crushed under this force of gravity is that the pressure inside our bodies is also equal to the atmospheric pressure and balances the pressure from outside.